And go home and rest because I feel terrible.
Sure. Take care of yourself.
Yeah, but you don't have to do anything. Like you can literally just shut down and walk out.
Okay.
So you're good to go.
Thank
Thank
you so
you again
much.
for doing this. This is going to be fantastic. I wish I felt better. I would stay and listen.
It's fine. Thank you. Okay, so I want to thank everyone for coming. Thanks for taking time to come listen up for this workshop. And I hope you enjoy it, and I hope you get enlightened and have more knowledge about recommender systems and how you can build yours and how you can change the state of the art out there. So before I introduce myself, I like to know like the people that are here. So maybe you can just tell me your name, your discipline, and what you hope to get from this.
My name's Tyler. I'm a computer science undergrad statistics. I'm really interested in pursuing a career in machine learning, so I'm just here to find my way.
Okay, nice to meet you, Tyler. Hi.
I'm Sarah. I'm PhD in Skype.
Mm.
And I am working on the research that I'm working on is related to analytics.
Oh, great.
For algorithms. So it's going to have some sort of repetition as well. I'm not a computer scientist at all. And I have lots of difficulties, but yeah.
Okay, that's interesting. I hope you get to know more about where to start from. Yeah, from this workshop. And you?
I'm Sukhi. I'm a master's student here at the Institute of Advanced Analytics.
Okay.
So I'm a master's in analytics.
Interesting.
And I want to move towards data science.
Oh, okay. Yeah, you're on the right track. Data science is like the big thing out there right now. So, yeah.
Hi, everyone. My name is Tulu Tunde. I'm an HRIS consultant, SAP consultant. But I'm hearing about machine learning and AI and how it's going to take over. So I'm here to learn more and to see if I can switch. So I don't become a dinosaur.
Okay, thank you very much, you guys. We don't have a big classroom, so it's just just a few of us here, so feel free to just stop me anytime and ask me any questions as we go on. Okay, so you guys are doing a good job of introducing yourselves. My name is Ruth Okoindo Akintunde, and today we'll be talking about an introduction into recommender systems, and that is a very huge building, part of the huge building blocks of AI of the 21st century. Okay, so a little bit more about me. I'm a PhD student at NC State University, and my research interests include applying and implementing deep learning and machine learning algorithms, techniques, architectures to solving real-world problems. And my goal is to improve the existing machine learning algorithms. In the past, I've worked on detecting critical moments in student learning processes and tracing factors that contribute to knowledge gain in the areas of STEM. On the screen, you can see an intelligent tutoring system, and that is where what I actually improve. So basically, it's similar to your normal Coursera or Khan Academy, where you go and learn any field or discipline you wish to. However, this system is smarter than those other systems in that as students learn, it tracks their eye movement. So the red dots you can see on the screen are eye movements of a student reading this content. And so what I basically do is to get the eye tracking patterns and use it to predict if the student is actually learning or not. And the benefits of this is to leverage the power of deep learning architectures for multimodal data analysis involving log files and eye tracking records. So the study is yet to be published, but it tries to predict if learning can be detected using eye movement patterns and eye actions alone. And the result of the study shows that eye movement can tell a lot about whether a student is learning or not while studying on an intelligent tutoring system. So basically, my goal is to advance personalized learning tools for easy mastery of STEM subjects. So if the system discovers that with this pattern of reading this content, the student has not learned anything, the system will interrupt the students and intervene, offering some instructions and advice on what to do, and just some more information on how students can better comprehend this content. So that is, I'm also interested in designing and improving personalized learning on virtual and augmented reality learning platforms as well, and also designing intelligent tutoring systems for students with disabilities. Okay. Okay, so in the olden days, they had eye trackers in form of eyewear, where you get to wear this eye trackers, and then as you look at the screen, the computer captures where your pupil actually hits on the screen using some infrared signals that it sends to your pupils. However, these days, because obviously that would actually interrupt the students while learning, you don't need to actually have any distraction. So these days we have very smart eye trackers that you can just place on your computer, and then it sends infrared signals to your pupils. When it detects your pupils, it detects the movement and then provides us the coordinates that you've been looking at in the log files. So yeah, so it logs the coordinates on the screen. So yeah, thank you for that question. Okay, so the whole of this presentation will be running inside of a Jupyter Notebook. So this is not a PowerPoint, this is a Jupyter Notebook RISE slides. And it's really cool and interesting to work with. Feel free to raise your hand if you have any questions during the presentation. We have all introduced ourselves. I'm Ruth once again, but this gentleman walked in here.
My name is Jeff Essig. I'm a data visualization operator for PHU.
Thanks for coming. All right, so a copy of this presentation and the hands-on codes that follow as well as the data sets we'll be exploring and working on and analyzing during this session can be found in this link. So just go to go.ncit.edu/recommender during the hands-on section to access the code. So you're good for now. Also, I'll be using the version of Python I'll be using is 3.6.8. So if you've installed Python version 3, that's good enough. Okay, now to the business of today. After today, you would have understood the trade-off between privacy and convenience. You will have a brief overview of AI today. You also have an overview of recommender systems, the methods involved in building a recommender system, and you will implement one or two approaches to recommender systems at the end of the day. So I hope you guys are excited. Yeah. Okay, let's talk about AI today. We'll see that Amazon, Google, Facebook, Microsoft, to mention but a few, they are all big firms that are currently in an AI talent battle, and I believe we all should join in as well. So one reason is that this AI industry is a ginormous gold mine, and especially in the area of personalized advertising. So these days, there are APIs that can provide information about a user's location and whatever is going on around these users, like weather information, just basic local information about that user. And they get it through your smartphones, your wearables, and everything you connect to the internet. So particularly when these users tend to rely absolutely on technology. So you have Alexa-powered homes, your conversations are being analyzed, your shopping preferences are gathered and garnered to give the machine an idea of who you are and what you do daily. So all these APIs collect data that could be used for effective personalization. Privacy and convenience. But I have a question. I talked about collecting all my data, but this is my data going out there. What is my data doing out there? What is my information about the time I sleep or my conversations, my private conversations in my bedroom? What is it doing out there? So the answer is that it's an unconscious trade by barter, where you exchange your privacy for tailored technology and convenience, which most of us enjoy. I don't know if you enjoy this technology that's going on around, like Walmart's reminder to reorder items and Netflix useful movie suggestions. So sometimes you use OK Google's advice to put on an extra clothing because your local weather says it's gonna be freezing cold. And so you don't have to type anymore. You can just speak to the computer, speak to the phone, and then it gets whatever you want, whatever search you want. So although they claim that this technology has advanced to the point where it's possible to actually anonymize your data, they don't collect your name, that's what they claim. They don't collect details about you that you put in to pay for stuff, like your credit card details or your social security number. They claim they don't actually collect that. And while they run this complex AI algorithms to get this technology to you, and what they call this information is basically PII, that's personally identifiable information, something that could be linked to you and something that people can say, maybe if the developers are working and say, this is this person's data. So this is called PII. So they said, okay, we got you, we have your data, yes, but it's anonymized right now. But how are we really sure it's anonymized? Some people got uncomfortable with this and they put Facebook's founder, Mark Zuckerberg, on the hot seat. And so it's not surprising that this first statement he made in the famous Facebook F8 conference in 2019 had the word privacy in it. So it's that bad that he had to talk about privacy, and that was the first thing to talk about. Let's listen.
Hey everyone, welcome to F8. Today, we are going to talk about building a privacy-focused social platform. Privacy gives us the freedom to be ourselves. So it's no surprise that the fastest ways that we're all communicating online are private messaging, in small groups, and in stories. This is the next chapter for our services. I get that a lot of people aren't sure that we're serious.
I don't think they're serious.
I know that we don't exactly have the strongest reputation on privacy right now, to put it lightly. But I'm committed to doing this well. And this vision is based on 6 principles. First, we're committed to working openly. Now, second, we're taking a more proactive role in making sure that all of our partners and developers use our services for good. We're also building out a lot of deep technical infrastructure, replumbing the whole infrastructure that we build for this company to support this privacy vision. It's not going to happen overnight, so let's start with our messaging apps.
Okay, thank you, Mark. That didn't sound reassuring though, but let's wait and see what they do, right? So he promised one thing, that, okay, we have your information, but we promise we are using it for good. Oh, but how do we know you're actually using it for good? How do we know you're not using it to influence our decisions in one way or the other? Okay. So there are questions online saying, is Facebook actually listening to your conversation through your microphone? Is there something running in the background? Because we have Facebook applications, Instagram, running in the background, and they really listen to your day-to-day conversations in order to tailor adverts to you. Some people have claimed that they talked about getting a mattress in their bedroom, and they saw an advert of a mattress while using Facebook. So how do they know what I like? How do they know what I want? How do they know what I want to purchase? How do they know to recommend this product to me? Today, we will learn how Netflix knows that I will like Napoli Ever After. You know, I did not tell them I'm a Black girl or I love romantic movies, and they didn't make me feel any form either on what kind of movies I like, what kind of genre I like. So how do they know? How does Facebook know I need a new phone? Why do I keep seeing this ad to purchase what I talked to myself about getting last night? How does Amazon know that this product is a perfect Father's Day gift for me? So for my dad. The answer lies in recommender systems. So recommender systems have become very popular and irreplaceable in the world of data science. Recommender systems are also called recommendation engines, recommendation architecture, recommendation framework. So it's just a similar name for recommender systems. And these systems can predict your preferences, what rating you likely give a product. They can predict what you'd like at this time of the year and at this period of your life. For example, if you search for wedding dresses because you are about to get married, don't be surprised that you would see so many adverts about destination weddings and hotels you could use and everything that has to do with weddings around you. So they're actually tracking you. How do they do this? All big tech giants will pay you a ton to actually improve their current recommendation engines. And so it's a good thing you're here to learn the basics of these systems, because the right product to the right person at the right time guarantees a purchase. It guarantees engagement. And what business doesn't like an addicted customer, you know? So in fact, Netflix offered $1 million in 2009 to anyone who could improve their recommender systems by just 10%. So if they have like a 10% better accuracy, that if they recommend this product to you, you actually buy it. If they recommend this movie to you, you actually watch till the end. If you can improve that, that ensures engagement. That ensures people subscribing for the next month and the next month and the next month. And this group actually won, and they were given $1 million. Okay, so I have a question. How does beers and diapers go together? I don't know if anybody has heard about this story. Oh, nobody has heard about the story. That's good. That's good. I'm happy to be the first person telling you about it. It's actually a myth that has been passed down from, I think it's the actual story started in 1992, and then different versions have been passed down to me, to different people, and then to me. So you can read about the actual story. I think I kept a link there, but I don't think it's there anymore, so I'll try to put it. How does beer and diapers go together? So in 1992, a retail store had some smart engineers try to analyze the receipts that they get from the merchant's copy of the receipts. And they discovered that, they discovered that men between the ages of 30 to 40 years, they have your data, they have your age. Shopping between 5 to 7 p.m. on Fridays, who purchased diapers were most likely also to have beers in their cart. So how does that work? Maybe mother is trying to get diapers on Friday night, and she's so busy and like, please, honey, help me get diapers. And then they go to the diaper aisle, they grab the diapers, and they're like, okay, I think I need a beer. And they walk all the way to the beer aisle. Or sometimes they might not be too lucky to have so much time to walk over to the beer aisle. So the recommendation was that put these two items together and you will always get a sale. Like every time you always get a sale. And so that was like, I think this is like the legend story of recommender systems. So that is that. So the first time I heard about recommender systems was when my college professor in 2010 told me about this study, and that blew my mind, you know. It has actually been existing since 1992, even before then. Okay. So AI did it for this guy. Recommender system did it for this guy. I don't know if you know him. Great, Jeff Bezos. So that's the CEO of Amazon. And how many people have bought something on a Black Friday here? Okay. Okay, great. So what they did was to analyze all their users, and they found out what items are most likely to be purchased and what items will be purchased at a discount rate. So the other scientists came together, sat down, and they said, if you put this discount rate on this item, this much people will purchase the item. But if you put this little discount rate, this is the sale you get. And with that forecast, they are able to actually mark items and put certain discount rates on certain items. So the discount rates you see on your items are not just random. They didn't just randomly put them there. Data scientists actually did some manipulations and tried to see how they can make the most of that Black Friday sale. And he rose to become the richest man in the world after Black Friday. And that is what AI can do for you. That is what recommend that system can do for you. So AI could help predict what product to place a discount on and how much discount should be placed on such products. And recommending the right products with the right discounts can definitely ensure purchase. Okay. So, right, I think I'm going back. So let's talk about the methods involved in building a recommender system. There are two most popular methods behind these systems. The first is called content-based method. The second is the collaborative filtering. The words might not be intuitive right now, but when I explain them, you would get a sense. A third method is worth mentioning. However, it's just a hybrid of the collaborative filtering and the content-based approach. Okay. So here, a user is recommended a product based on the features of the previously purchased product. So you search for sneakers online, or you purchased a sneaker, that's a footwear, or you purchased a pair of sneakers, and then you are recommended, in this method, you'll be recommended other brands, or you'll be recommended other types of footwear like sandals based on the weather and based on your local information. And you could also be recommended socks and shoe polish and other things that are similar to that item you purchased. That is content-based method. So it depends on what you bought, and that's what they would recommend to you. Whatever you bought, similar items will be recommended to you. Okay, so it basically exploits the semantic relationship between these purchases. So when we talk about semantics, semantics is one topic that is really interesting right now in the UK, not here. It's interesting in that it plays with words. So it draws this large graph where that's not big enough. But if you can just squint, you'll be able to see. It draws a large graph around the items and shows you connected items. For example, if you watched a Tom Hanks movie, these big firms already have these graphs existing in their database that links other types of Tom Hanks movies, and then they recommend this to you. So that is one way to.
Just be like LinkedIn where you give recommendations to people to
Yes. Yeah. So this approach is mainly used by social networks like LinkedIn and Facebook to recommend friends to you. So based on many factors, it could be based on similar work experiences, it could be based on friend of a friend. And so that is where this method is really useful. Okay, but it has a downside, especially if you are using it to recommend products. It's not refreshing. When I purchase a pair of sneakers, right, I don't want 10 pairs of sneakers. So why do you keep showing me different brands of sneakers? It's not refreshing. You don't give me other types of products. You just give me similar products, this product. For example, I watch a romantic movie and you don't even break out of my genre. You just keep giving me different romantic movies. I might be interested in sci-fi for all care. Could be interested in other kinds of movies, but this approach just gives me similar movies. It's not personal. That is another downside to this approach. Because whenever anybody purchases a pair of sneakers, it doesn't look at my taste to recommend other products to me. It can recommend the same pair of sneakers to another person and another person. So it's the same result. They don't consider if you're consider your personal preferences. So the same results for everybody. Similar products is given to everybody. Okay? The upside is it doesn't face the cold start problem. So I will come back to explain what this cold start problem means when I'm explaining the second approach. If you have any question, just let me know. So this is the second approach, and it's the collaborative filtering method. So this method groups users into similar groups based on the items they purchased in the past. So let me repeat that. It groups users into similar groups based on what they purchased in the past. So if we have two users that purchase these three items, they go into a group. So let me just use a short exercise to demonstrate that. Okay. So we have 5 users, and the first purchase of user A was a tablet, and user B did not purchase anything at that time. C purchased the tablet. D purchased the tablet but did not like it. Maybe he returned it. E purchased the tablet and kept it. And the second purchase was a notebook. And A purchased it, did not like it. B purchased it and liked it. C purchased it and liked it. D did not purchase it at all. And E purchased it and liked it. From the first 2 items, can we find one group, one cluster of users that love the same product or they hated the same product? Does everybody agree C and E? B and E. Okay. So someone said C and E, and another user said B and E. So C and E could be B and E could be a group. However, C and E is a much closer group. Can you see? Because they purchase more items, similar items together, more than B and E. So let's go with C and E. Okay, so let's establish now that C and E will be in the same cluster. So now, the next action C performs is to purchase a laptop and he did not like it. Will the laptop be recommended to user E? Will the laptop be recommended to user E? C purchased the laptop, he did not like it. Based on the fact that C and E are in the same cluster, will the laptop be recommended to E? No. Correct. The laptop will not be recommended to E because C, who is in the same cluster as E, did not like that laptop. And so this recommended system will not recommend the product to user E. And that is a summary of the basic function of a collaborative filtering method. So, okay, clusters. Okay, now I think I'm missing something. Yeah, the downside to collaborative filtering approaches. First, cold start problem. As we saw previously, if no item is purchased, we don't know what group the user falls into. I'm trying to go to the previous slide so that I can see. Okay, here. So we could not put group D or group B into a group, a correct group, because based on the first item, because he has not purchased anything. So we don't even know what to recommend to him. So that is called the cold start problem. We don't know what to recommend to him because we don't know him, we don't know anything about him. But the content-based approach will not face the cold start problem. Can anybody tell me why?
I've got a question. So we're looking at 5 samples, but in reality, there's going to be hundreds and thousands.
Millions.
Yeah.
Yeah.
So in that case, you said that E does not get the recommendation, but if there are many more that do recommend it, does the programmer set a threshold for where
Correct.
the approval has to be a certain threshold?
Yes, yes. So that's a good question. So in case one user in the cluster doesn't suggest it, that does not mean other users in the cluster do not like it. So the programmer could set a threshold saying if 70% of people in this cluster like this product, then I would recommend this product to the user. And so they use that threshold, and that's what research is called. So they use the threshold, they check if the user E buys it. If the user doesn't buy it, they reduce the threshold, or they increase the threshold. If 80% of people buy it, then let's see if he will buy it. And so they keep moving to get a better, a more efficient recommendation system. That's why they work day and night and they earn the big bucks. Right. So can someone tell me why the content-based approach will not face the cold start problem?
So they already know what is, for example, genre, so that they have the information about themselves, so they don't care about the user.
Okay, so they don't need to create a group for user based on past. So if you just purchase just one item, I can give you a bunch of recommendations based on the things connected to that. Right. Okay. Also, the model needs to be updated regularly. Just like he said, you have to evaluate the model and then see, or if as more items are being purchased, you need to regroup people and recluster people into different groups as more items are being purchased. So the upside to this is that it works well in providing cross-domain recommendation. So we see how diverse these products are. Like a notebook is different from a laptop, it's different from a game system, it's different from an iPad, although they are all electronics, but in case they are not electronics, they could be food items. And it gives you a diverse recommendation system, and then it creates fresher and diverse recommendation system, as I said before. So, and another thing, reason I like the collaborative filtering method is because this is Amazon's website, and this is a new user called Green, and all the things being recommended to the user is based on his local information. He has not purchased anything, but they know that he lives in the US and Father's Day is around the corner, and so they get to recommend Father's Day gift items to the user, because they basically don't really have much information about this user, but at least they know the local information about that user and they could recommend it. So this system can actually bypass the cold start problem and give you very good recommendations. And you'll be surprised how many new users click on that link because they want to get a gift for Father's Day. Okay, now we get to the reason why we are here. Many of us want to know, how do you actually code these things to get it to work? How do you actually achieve this? So I hope we are ready to code, right? It's fun. Coding is fun. All right, so I'd like you to go to the link. Go to ncse.edu/recommender. You can follow the steps all through to the last instruction and just let me know if you face any issue. When you get to the last instruction, just raise up your hand. Okay, good. Okay.
I don't think so. I'm using a computer.
Just click it. Yeah, you can take like a 2 or 3 minutes break and stretch your legs. We'll start right back around 1:15. So that should be good. Okay. Okay, let's proceed. So the first one, because I really like this approach a lot, so we'll be doing an example on collaborative filtering. And if we could do a little recap, it involves us clustering users into similar groups and then taking those items, the items that the users have loved, and then recommending other users have loved and recommending it to this new user. So basically, if John loves it and John is similar to Mary, it's likely that Mary will love it too. So if John loves it and John is in the same cluster as Mary, then it's likely that Mary will love it too. So basically, this approach calculates similarities between the ratings. We'll be using a movie database. So we'll be using something like IMDb's database, where users have seen a movie and given it a like, 5-star, 2-star, 3-star. And I don't know if you've heard of Rotten Tomatoes, where people go and rate movies. And so if John and Mary have watched this common set of movies, we make them be in the same cluster. Okay. So from what we've learned right now about collaborative filtering, can anyone tell us what kind of data or attributes we need to collect from the user to actually do this collaborative filtering? Yes? Reviews, ratings, yeah. Is there any other thing we need to collect from the user?
Other demographic profile data.
Okay,
Sage.
okay,
Things like that.
okay. That's a good answer. Let's see. So, all the movies all users have watched and the ratings that they have given these movies, that's like the minimum we need to have to build a very, maybe 70% accurate recommender system. But if you want to go deeper, like you said, we could collect their demographics, like their age, their sex, their gender, and other information to create a more robust information. But to do just the minimum collaborative recommendation, we need just the movies they've watched and what ratings they gave to that movie. And that would give us this information. That would help us with this. So we need attributes, right? In data science, we work with data, and what we work with is attributes. And attributes are known as independent variables, and they predict something. So we need attributes to plug into our machine learning algorithm to make for a prediction. So the attributes we need right now are just 2 columns, 2 attributes. One is the movies, obviously the user names, the movies they watched, and the ratings they gave the movies. So let's proceed. Okay, so the code I used in this section was adapted from AI Society, so you can actually modify it for other data sets. They used it to recommend books on the book recommendation site, but I am adapting it for recommending movies. So the first step is to just import the libraries we need. And so the code has already been written for you. You just need to click on run and just click on it and run. If you need me to help. So click on that section and click run. And let's go to the next code, which is to read the data sets into our Python environment. And so if you check the folder which you got from GitHub, it could be in your downloads, you'd see that there's a CSV or an Excel file called 20 user ratings.csv, right? Everybody's seen that. So what we are doing right here with this pd.read_csv is to read this Excel file into a variable called ratings. And so when we do ratings.tail or ratings.head, and you specify a value, it gives you the last or the first 1,000 items in the Excel file. So as we can see here, you can see that this ratings variable contains user ID. This is user 11, and his name is James. And the movie ID that he has liked, as well as the ratings he has given to this user ID. The data set also contains the timestamp these users actually rated these movies. And so you can see that these are all the movies James has watched, and there are other movies Justin has watched as well, and the ratings he gave the movies, as well as Sarah. And if you play around with exploring the data by adjusting the value of this ratings.tail, you can make it ratings.head to see the first n users by changing the value inside the braces and the parentheses to any value you want to see. If you want to see the first 5 users, say ratings.head and specify 5 in this place. Is everybody okay with that? Okay. All right. What is
index of fonts, which is in the data? And the streets, CSV.
Okay. Okay, yeah. So whenever you read files into CSV, by default, it gives it an index and then creates another column in front of the table, which we don't need, and from 0 to the last value. So it gives it an index. Yeah, we already have the index. It's not a part of it, but if you don't specify index underscore call, it creates another column in front with the same data with the same index, and we don't need that, right? So we say index underscore call, that's false. Yeah. Okay, running the next code, we want to see the users in our data set. So now we've read the data set into something called ratings, is a variable, and then to find all the users, even though there are millions of rows in the data set that has all the movies the users have rated, we want to see the unique users, and we have 20 unique users, and they are listed here. Okay, if I'm going too fast or too slow, just let me know. Maybe we have smart gurus here and just want to go fast and fast. Let me know. And if you think I'm going too slow, just let me know. Thank you. Okay, so I like to keep a copy of my original variable, so that when I work with the variable, I don't change the original content. So I do ratings.copy and put it into ratings.date. They contain the same thing, but I just want to keep ratings separate so I don't get modified. So I'll be working with ratings underscore dicts. That's what I'll be working with right now. So the next set of code is not so straightforward. I'm going to create a dictionary from the table that I already have, a dictionary of all users, the movies they've watched, and the ratings they gave it. So basically, I'm just converting the table I already have to a dictionary. So what I did was to take for each user in my database, for each user, the 20 users, for each of the 20 users, take user 1 and get the username, and so extract the movie title and the ratings and put it into this guy, and then put it in a dictionary. And so this is what I have. I have Amanda. The first movie she watched was Pet Detective. She gave it a rating of 3.0, and she watched the second part of this movie, gave it 1. Watch Aladdin and that. And if you scroll down, you see other movies. Which what other users? Next user is Andrew. He also watched this movie but gave it a 3, and on you see other users and the movies they've watched, as well as the ratings. So this is Daniel and David and the movies they've watched. So basically, I just put the table into a dictionary. And the next thing is to put similar users into a cluster. So we're going to write a function that calculates similarities between two people. And in computer science and mathematics and statistics, we have a distance matrix or a similarity matrix called Euclidean distance. Okay. Okay. What does zip do? Okay. Okay. So when you want to create a dictionary in Python, this is the function you call dict, and so you have to zip the key and the value. So this is key value. The movie is the key. The rating is the value. So you have to zip the key and the value and put it into the dict function in Python. Okay. So, as I was saying, in computer science, you have calculations that, algorithms that calculate the distance between two numbers. I don't know, is there any computer science here? Computer science, yeah. Have you heard of Euclidean distance, Manhattan distance, and Mahalanobis distance? All these are distance metrics by very smart mathematicians that calculate the distance between two numbers. So if you have an XY coordinate and you have this point here, this point here, this is one distance between them. This is another distance between them. So the Manhattan distance is just the straight distance between them. Distance between these two values. Euclidean distance is the calculation between the distance when you go from here to here. That is the Euclidean distance between 2 points. So that's what we'll do. We'll use Euclidean distance because it's more realistic to solve problems and it's been shown to work for collaborative filtering. So what we want to do is to calculate the distance between the ratings, like ratings 2 and 1. If someone gives a movie 2 and someone gives another movie 1, across all the movies. So take two users, take all the movies that they've both watched, and we'll see the ratings, the distance between the ratings they gave them those movies and sum them up. And so that's what this function does. And so if I have a user that both of these users have watched 10 movies in common, and they've given different ratings to it. They might be similar sometimes, they might be farther apart, similarities, like if I rate something a 5 and the other user rates a 1, the difference is a 4. And that's so much. That's the big difference. The similarity is large. So the smallest value, users that have the smallest value will go into the same clusters. And so that is what this function does. So this is now the ultimate function that does our recommendation.
So what does this function do? This function takes in the name of the person we want to recommend for, the bound. What is bound? Bound is the number of recommendations we want to give. If we want to say, give me the first 5 movies. So that's the bound. And then what metrics do you want to use to cluster this user? The metric is the Euclidean similarity, which we already defined before. And so it takes in the person, takes in the number of recommendations you want to display, and then takes in the similarity metrics you want to use. And so it uses this to create a score. And the score is the similarity between this person and other people. Yes. So the similarity between this person and other people. How does he know other people? Yeah, this person and other people. Other people, this code basically means other people that are not equal to this person. So that's how he knows what other is. So for other people in this data that are not equal to this person, give them to me and calculate the similarity. And put all their similarities into this variable called scores. Sort them in ascending order and give me the first 5 people. And it puts the first 5 people here and comes down here and says, for the similarity ratings in scores as well as other people, now for each of the similarity ratings, give me the scores, the rank scores, put it into this function here. And then for all the rank scores, give me all the movies. This one will contain five people, right? Because we just need the first 5 people in that cluster. And so it says, give me all the people, give me this person. Sorry. If the movie is not in the movie this person has already watched, right? Then rank it and give me a weight. Give me a rating that a predicted rating this person will give to this movie. If the movie is not in the movie the person already watched. So after now you can go and do like a print statement, because I use print statement a lot to see the values inside these variables so that you can see how the code flows. So if item is in recommendation, calculate a weight for it. Calculate a weight for it. Else, calculate a different weight for it. So after that, we then display our first 5 movies. We display our first 5 movies based on the bound from 0 to whatever we've set here. And then we sort it and then return the first 5 recommended movies. That is how this code works. So it's a function that takes in the person you want to recommend for, the number of movies you want to recommend, and then the similarity metrics you want to use. So let's try to run that. So going on to the next code, you'll see we want to use the method we've created right now. So I'm a data scientist in my company. I've created this cool method, and I want to recommend movies for a new user that just signed in. What will be the first 5 movies he's going to see on his dashboard on Netflix? I take in the username or ID because they claim they don't use the name. So I take in the user ID, but in this case we use the name. I take in the first 5 movies. You can change to if you want to see the first 10 recommendations. And then I put in the metrics I want to use. and then it gives me these movies and the predicted rating. So it's predicting that if he watches Mighty Aphrodite, it's gonna give it a rating of 5 and 5. And if he watches Gladiator, it's gonna give it the movie a rating of 5. And so you can, for the next 5 minutes, play around, or maybe 2 minutes, play around with the variables by changing the name of the user. You can pick one user from the previous users we've created and change the number of movies you want to see recommendations for. Are we seeing interesting results?
Got some results here. 5.000002.
That depends on how confident the ratings. I'm not sure. It's based the difference in values between how the ratings were given data. Based on the rates, just results the same. So let's quickly see how the content-based approach calculates, recommends items to users. So this code was also adapted from DataCamp, and you can go on there to check it out, and you can modify it as well for other data sets. So a brief recap of what content-based is. So this approach takes in the items you bought and checks its graph to recommend to you what next product should be based on the similarities in the products you purchased. So now, quick question. Can we use the previous data set for content-based filtering, or do we need some attributes, some other attributes? Let's see. So this is the previous data set. It has this. You were saying something?
Add some attributes about the product itself.
Yes, correct. We need to add some information about the movie or whatever about product to be able to check for similarities or check our graph for that.
So let's go.
So we'll need details about the movie because we want to recommend a similar movie. So we could have details like the star in the movie or the movie plot, the genre, or other details about the movie. So the database we'll be using has lots of information. So the method we'll be using is called pairwise similarity scores for all the movies. Hello? Hello? Hi, hi, hi. I think there's something wrong here. Maybe the battery is gone. I think the battery is dead. Okay. Okay, that's great. All right, he's gone. So
I can, I'll send something downstairs.
okay, so I said we're gonna do like a pairwise similarity scores between the movie plots. So let's see how that looks like. So the data set is from IMDb. It's a movie database that contains 45,000 movies. And if you run the next code, we are simply loading the Excel file that contains this movie, the CSV file, into a variable called metadata. And so, as we did in the previous variable, we checked for the first 5 items on this data set, and we can scroll left and right to see the first 5 data sets. Okay. The attributes of the first 5 data set. We can see that the data set has some attributes like if the movie is an adult movie, if it belongs to a collection, the budget, the genre, the page, the ID. But what we'll be using is the overview. We want to see the similarities in the overview of the movie. So the overview is also known as the plot. Like this one says, when siblings Judy and Peter discover an enchanted blah blah blah. So we want to see if there's a similarity between all the plots of this movie and see how we can recommend it to different users. So you can go ahead and run that code and run the code after it that says metadata overview .add. We just want to see the first 5 attributes, the first 5 observations of this attributes overview. So we want to see the similarities between the first overview, the second overview, the third overview. By looking at it with your naked eye, can you see any similarity between these first 5 movies? Any similar words? Not really. Similar words? I can see and, A-N-D. And is a similar word between 1 and 3, right? But it's meaningless, right? So what our system will do is to first of all remove all the stop words and articles that are not useful for us. Remove all the common words like at, on, by, the, comma, to remove everything and try to look for similarities in important words like Woody, siblings, family. So if two movies have family in there, depending on the calculation of the similarity, I could recommend those two movies to one person that's watched something that contains family.
Similar words like toys and siblings.
Toys and siblings. Yeah,
Siblings.
that's the semantics. That's another level of content-based filtering. So we're not using the exact words now. We're using synonyms of the words to calculate similarities. So that's like an advanced algorithm you can use. But for this example, we're just going to use the exact words. Toys. If two movies contains toys, there's high probability that I would recommend it to somebody. So in other advanced systems, we can have synonyms for toys and then recommend that to people. And it could not be synonyms, it could be toys and children. So when you see toys and children, you know that those are movies that this person can enjoy. So the first step is to compute the pairwise similarity between any two plots. And then to do this, we will need to convert these plots into something called term frequency inverse document frequency vectors. So this is a computer science term for natural language processing. So now we are kind of delving a little bit into natural language processing. I don't know if you've heard of natural language processing before. Natural language processing is another huge branch of AI that deals with Alexa talking to your phone, processing natural language. Yeah, so whenever you speak to your phone, they first of all take all these words and they convert it into this format, removing all the and the in and all the stop words and search for whatever you want to search for. Maybe you say, okay, Google, will it rain today? So it removes all those things and just processes the rain, the important words in the sentence you give it. So that is just the basics of what natural language processing does. So basically, when they have sentences, since we are processing sentences, we convert it into this format. And this format is a matrix. It looks complex, but it's not really. It just contains all the words stripped off with the stop words stripped off. All the words are the columns, and the movies are the rows. So the values are 1 and 0, 1 and 0. So if you see family, and this movie doesn't have family, it gives it a 0. And I don't know if I can, are you following me? So you have family, toy, enchanted, some other things. And you have the movies as the rows. And so if that movie doesn't contain family, toy, it has 0, 0, 1. Maybe if it contains enchanted. So we have family, toy, enchanted, 0, 0, 1. Maybe the next movie contains the 3 words, it has 1, 1, 1. The next movie doesn't contain the 3 words, it has 0, 0, 0. So it's like a table of words versus movies. And then from there, we now have it in like a mathematical form, right? Words and movies. Now we can calculate the similarity between them.
That's what you call it, matrix.
Yeah, it's a matrix of words versus movies. And then, yeah. So this code basically calculates and turns it into a matrix of 45,000 movies and 75,000 words. So all these words that they used in the plot, after removing the and the articles and the stop words, you have 75,000 plus English words versus 45,000 movies. So there's something called cosine similarity, aka linear kernel. It's another variation of the Euclidean similarity we used before, but cosine similarity has been found to work better with research. Research found it to work better comparing words comparing similarity between words than Euclidean similarity. So we're using the cosine similarity. And if you read more about the cosine similarity, in Python it's very slow, but you can achieve the same result using the linear kernel function. And that is what I did here. So I'm finding the similarity between each movie and putting it into this variable. So the next step is to write a function called getRecommendation, just similar to the recommend function where we had to put Michael and 5 and a similarity metric. So this is the recommendation function we create. This code basically is part of the next code. It prepares our data to be plugged into this method. So we're taking the title of the movie and taking the type of metrics we want to use to calculate the similarities between the different plots. And the next thing is that we have our recommendation method. We plug in this movie title called The Dark Knight Rises. And what do we have? It gives us the first 10 movies. And what do you notice? Huh?
More dark is used a lot.
What do you notice about the recommendations? Yeah, they're all Batman movies. So it's not refreshing, right? I don't want to keep watching Batman movies like every day. I want to watch like a different movie. I'm interested in other movies as well, right? And that's why we have the hybrid method. The hybrid method tries to take the good things of both methods and then either shuffle it by giving weights. Maybe I would take 70% of the recommendation from this method and I'll take 30% of the recommendation from this other method and display it to the user. Or maybe I will even go a step back by changing my algorithm, merging the two algorithms together. So there are different ways to do it. You can either give weights and say, I'll just take 2 of this movie and recommend to the user and 5 from the other method and display to the user. So, and there are more complex methods than this already. I'm sure the big companies will use more complex method than this. And so that is it. So you can also put in any other movie and see the recommended movies given to you. Let me know if you have any question. So what is the disadvantages? What is the disadvantage of this approach? We already saw that. We already discussed it. So it's not refreshing. Okay. We put in The Godfather and he wants us to watch all 3 Godfather movies. But at least he still gave us some other, because there are only 3 Godfather movies, so he gave us some other similar movies to that kind of movie. But how can we tell that this is actually what the user wants to see? It's very detrimental to okay. It's very, see, you guys should be happy, we're almost done. Okay, so it's detrimental to have, it's costlier to recommend something that I would not buy than recommend something that I would like. So it's costlier to recommend to me. So false positives are undesirable in this company. So if you're a data scientist working for Netflix and your algorithms have a lot of false positives, that's how you evaluate the recommender system. If it has a lot of false positives, meaning that my recommender system tells me customer A will like this product, whereas he ends up not liking it, that is detrimental to my company. It's better you don't tell me he would like it at all. It's better if you know that he might like a product, it's better you don't tell me than to tell me you will like something that he will not like eventually, because it discredits the recommendation systems. It makes people not want to watch Netflix anymore. You just recommend bad movies to me and I don't really like it. So they try to improve to reduce the number of false positives they get when evaluating systems. So you can research on ways on improving recommender systems and ways to reduce false positives. And thank you for coming. Happy recommending. Let me know if you have any questions. I've kept some resources here. Maybe you want to play with other kinds of data sets or read books or tutorials. I don't know if you've heard of Kaggle.com. Kaggle, yeah. So if you want to try your skills, your recommendation system skills, go through the tutorial we just went through, learn the methods, and okay, you can go.
Yeah. So is it important to use one content-based scenario before using grouping-based scenario?
The collaborative based.
Collaborative based. Is it important to use one for the other? Try to use one for the other. These different results.
Thank you.
First one is the second one.
Okay, that's a very good question. So he asked that if I want to do the hybrid, can I use one recommendation system first, and then maybe based on what that recommendation gives me, maybe I use collaborative filtering, and then it gives me a bunch of movies that I think it thinks I will like because I'm in a cluster where other users like the movie, and then I then go deeper and check the plots for these movies, and then use the content-based method to analyze the plots to get even better similarities between these movies. Or should I just start from the content-based, where it recommends to me all the Godfather movies, and then I then check to see if people in that cluster, in similar cluster, liked this movie. So which one should go first? So it depends on what accuracy that gives you. So if you create a system where you try to, that's called research, right? Research tries different methods and checks for the best. So maybe this month, Amazon tries to use the collaborative first, and then before using the content-based, and it sees that they don't really like or click on the movies, or they thumbs down the movies that they've watched using this method, they could experiment with this other method for this month, and they evaluate their methods. And when they see that, they end up using the ones that give them more profit. And so that's what research is about. Try to read the options. So I was talking about Kaggle. They do competitions where many companies just post different problems they're facing, like just saying, which one is better? So they might not want to label their data scientists. They might just want to throw it out there, and they put a prize, like, if you can give me a better accuracy, a model that gives a better accuracy, I would give you $10,000. You can work in teams or you can work individually. So all those competitions are on Kaggle.com. So you can just search and look for competitions around recommender system and just hone your recommendation skills. And there's something very important here. The thing is, when they work, everybody that has done that competition puts his code out there. So you can just go to kernel. There's a tab called kernel, and extract as many people's code you want and learn from them, right? Just extract their own solution and learn, because it will be beautifully documented because for evaluation. And so you get this code, learn how they did theirs, and even make yours better. Yeah, thanks for coming.
I noticed a lot of recommendations are a lot of sponsored recommendations. So I guess they're quoting, they're running the analysis within a set of products or whatever, or movies that have been paid to have their recommendation maybe at the top. So they're bringing that first and putting those at the top.
Yes, that's another way they do it. They will do sponsored recommendation as well. Yeah. Thank you very much. Okay, I hope you guys enjoyed it. Yeah, thank you.